Okay, quiz is tomorrow, but we're gonna be working from page 9 and 10. So we're gonna work through this review and then the worksheet that you picked up. Hopefully, you can use that as additional review for practice tonight for tomorrow's quiz. Okay, so you picked up both the blank copy and the key as a paper practice. Okay. So what I want to do is I want to go through one of each type of problem, and then have you guys finish off the rest of the worksheet. Okay. So page 9, your packet. So number 1, it says graph each point on the polar grid. Find 3 other pairs of polar coordinates that name the same point. Now, it doesn't matter which order you present these order pairs, as long as you have them there. So there's only going to be 4 variations because we have a restriction on our domain here. So for A and C, we're going to be using degrees, and for B and D, we'll be using radians. I'll do A and B together with you, and then you guys can try C and D on your own. But for part A, it says, I want to go 4 units towards negative 120. Negative 120, it may not feel as familiar to you, so I can always do what to make that more familiar. Add what? 360, right? I mean, we can also just subtract, just move with our understanding that we're going to that fourth quadrant first. But if I do negative 120 plus 360, that gives me 240. So basically, negative 120 is another way of saying 240. I want to walk 4 units towards 240. Which quadrant is that in? Plus 240 units. Quadrant 3. Okay, so I'm walking 4 units towards quadrant 3. So that means every point, every order pair that I create has to land at that same point. Now, once you're here, you understand that you're playing with the opposite quadrant as well in order to create more order pairs. So if you're in the 3rd quadrant, you'll be playing with, working with the 1st quadrant as well. But if you're 2nd quadrant, then you work with the 4th. So you're always working with the opposite quadrant to get all your order pairs. Okay, so 240 is another way of saying negative 120. So that's an easy order pair for us to write down. So both are landing in the 3rd quadrant. I'm walking towards the 3rd quadrant, so that's why I have positive 4. Okay, what is the 1st quadrant version or counterpart for that 240? 60, right? I can do 240 minus 180. That will always get me in the other direction. So 240 minus 180 is 60. So I can create an order pair using 60 degrees. But 60 degrees is in the 1st quadrant. I don't want to be in the 1st quadrant. So what I do with my radius, I got to walk away. So therefore, negative 4. So I have a 4th order pair that I want to create. And so I want to continue working with the 1st quadrant. What's another way of saying 60 degrees? Subtract 60, right? Because I just have to make sure that I land between what's given to me here. So 60 degrees minus 360. So negative 300 degrees is also 1st quadrant. So again, I want to walk 4 units away from 1st quadrant. Any questions there? Okay, so let's look at B, which is from the perspective of radians. So 7 pi over 4. Okay, where's 7 pi over 4 located? Which quadrant? Fourth quadrant? Yep. I'm walking 2 units towards fourth quadrant. So therefore, I need to make sure that every order pair I create lands at that same point. In this case, I'm going to be working with the second and fourth quadrant. Okay. So what's another variation of 7 pi over 4? Subtract what? 2 pi. So I'm just going to match common denominators there. Subtract 2 pi, same thing as minus 8 pi over 4. So I'm done with the fourth quadrant. Okay. But now I want to play with the second quadrant. What's the second quadrant counterpart for 7 pi over 4? 3 pi over 4. And then numerically, the way you can get there is you can always subtract or add pi to go in the other direction, right? So if I subtracted pi, if I subtracted 4 pi over 4, I get 3 pi over 4. My second quadrant is not where I want to be, so what do I need to do with my radius? -2. And now to create a different version of 3 pi over 4, I can subtract what? Subtract 2 pi, yeah. Okay, any questions with A or B? Guys, hold off on doing C and D. I want to just go through a little bit of every problem so you guys have a model to work off of. I think number 2 should be pretty easy. You're just using the distance formula. Just be careful that what mode you have to be in for A. Degrees. For B, you have to be in what mode? Radians, okay. And then I will give you this formula. Do you see that on the board? Yeah, I'll leave that on the board up there. The distance formula for Polish. Okay. All right, so let me. I think this is pretty straightforward. You guys can do this on your own. So let's go to the next page. Page 10. Find rectangular coordinates for each point with the given polar coordinates. So there's a formula to get from r theta into x and y. And that's x is r cosine theta, and y is r sine theta. And also, if you look on your calendar, the top third of the page is basically those are the what you're responsible for, converting from polar to rectangular, and also converting from rectangular to polar using Pythagorean theorem and inverse tangent. And then I'll give you the distance formula. All right, so once you have that, then it's pretty straightforward, right? Because it's just 5 cosine 5 pi over 3 and 5 sine 5 pi over 3. Okay, it says exact form, but I'll take decimals as well. Pretty easy, right? Because remember that formula. It's also carryover from the previous unit. Okay, so I'm going to skip B, C, and D. Have you guys try those on your own. Let's go to number 4. Number 4 says find 4 unique polar coordinates for each point given as a rectangular coordinate. Use negative 360, 360. So pretty much like that first page, but we have to make sure we can get it into polar form first. So for A, first thing we got to make sure that we are completely understanding here is which quadrant is this order pair in? Quadrant 2. So make sure that you are understanding that. So every order pair you create has to land in quadrant 2. Right, so these are x and y. We want to get into r and theta. So to get to r and theta, we have to use Pythagorean theorem, right? So r is square root of a squared plus b squared, or x squared plus y squared. To get to theta, using x and y, I have to use inverse tangent. Make sure you are in degree mode. Now we're always keeping an eye on where our location should be. Does this feel like a second quadrant degree measure to you? It's not, but it is very useful, right? It's a reference angle. It's related to reference angle. So how do we get to something that is second quadrant from this? Involve what? 180, yeah. Okay, so this is one variation of the order pair for my r theta. So now I'm sitting in the second quadrant. Right? It doesn't matter, again, it doesn't matter which way, which order you decide that you want to put all your order pairs in, but I'm just going to go through my way here. Let's say in the second quadrant here. What's another way of creating a second quadrant degree measure and falling inside this interval here? Subtract what? 360, right? So if I subtract 360, I can create another second quadrant degree measure. Which is 101 minus 360 is negative 258. If I'm in the second quadrant still, then my radius is still what? Positive, right? I'm still walking towards the second quadrant. All right, so now I've created something that's straightforward, second quadrant, but I know I can also play with the fourth quadrant, right? I can also walk away from the fourth quadrant. So how can I create a fourth quadrant counterpart of this 101? Add what? 180, right? If I do 180, I can always make that degree measure go in the opposite direction. The 101 plus 180 is 281. Okay, and then, but what adjustment do we have to make with my radius? Negative. Okay, so I'm sitting in the fourth quadrant. How can I create a different degree measure that's also fourth quadrant? Subtract 360. Yeah. And then if you're deciding, wait, should I add or subtract 360? Keep in mind what your range is, right? Because if you add 360, if it falls outside your range, you know, okay, I'm going the wrong direction. I need to subtract 360. You're always keeping an eye on that you're falling inside the correct interval here. Okay, so I'll leave you guys to do part B on your own later. I want to do C with you because this is in terms of radians, the same procedure, but it'll feel more abstract because we're not as familiar with the radian decimal values. Okay, so let's go to 4C. Okay, so now we're between negative 2 pi and 2 pi, between negative 6.28 and 6.28. Okay. I think it's always helpful to create this diagram here. 2 pi is 6.28, pi over 2 is 1.57, pi is 3.14, 3 pi over 2 is 4.71. Okay, we should not have to memorize these decimals. You can plug this in the calculator, pi over 2, 3 pi over 2, 2 pi, and get these decimals yourself, right? But having these decimals on your paper can help you look at those decimals and know, okay, which quadrant am I dealing with here? So let's start off with getting to our radius, which is Pythagorean theorem. Next up, inverse tangent. Oh, the first thing I neglected here, which quadrant is this in? Quadrant 3, right? So everything, that's going to be your foundation, right? Quadrant 3, everything is gonna land in quadrant 3. Okay, I get 0.524. I know it's not degrees, so it feels more abstract, but is 0.524 something that is in the third quadrant? Not right. So what can I do to get it into the third quadrant? Right, normally we would say plus 180, but this is radian, so we say plus pi. Okay, 3.665, that lands safely between 3.14 and 4.71. We know that is the third quadrant radian measure. So now that I'm clearly in the third quadrant, let's stay in the third quadrant. How can I create a different radian measure that's also third quadrant? Subtract what? Yeah, we will say 360, right? But this is radian, so we say minus 2 pi. So if I'm in quadrant 3, I can also play with quadrant 1. So how can I get this 3.665 into quadrant 1? Yep, subtract pi, right? Normally we would say subtract 180 or add 180, but in this case it's radian, so we subtract pi. But we're walking away from the first quadrant. So now in the first quadrant, how can I create a different version of the first quadrant? Either add or subtract 2 pi, but in this case, I want to do what? You're right, you're right. I got to subtract, right? If I add 2 pi, I'll be outside of 6.28. That's too far out. So you're right. Yeah, I got to subtract 2 pi here. Okay, so hopefully this was helpful in terms of helping you model every type of problem that you're going to see. And then now you can go back and try each of the problems on your own. Okay? And I'll put the solutions up one at a time. But let me know if you have any questions. I can help you along the way. You have to calculate do most everything, but some students from the previous class were asking about a blank unit circle, so that's fine. I'll make that available to you if you want to have a blank unit circle tomorrow. We'll be back in a few minutes and I'll show you the back page. So we sure. Okay, any questions on the first page? They keep going for 5 minutes.